Hello and welcome to Revision Classes on Television. Today, we will be having a session in mathematics. Our guide is Abiodun Idowu and our topic today is circle geometry.
Today we are going to continue with circle geometry. We are going to continue with this particular question on the board. If you look at the particular question on the board, we are required to find angle X. That is angle VUS. Now, to solve this question, let's mark this angle here as angle K. That is, this is angle K. The angle we have marked as K is angle SRQ. Then let us mark this other one, angle M. The angle we have marked M is angle VRS. This is to enable us to answer this question properly. If you look at this arrangement, angle K is going to be the same as angle 28 because both of them are angles in alternate segments. So I'm going to write K is 28 degrees. The reason for that, angles in alternate segments. So this angle K is now 28. Now the next thing we are going to do is to find angle M. To find angle M, you observe that angle 46, angle M, and angle K, the three of them lie on a straight line. So the sum of angles on a straight line is going to be 180. So we are going to approach it from that point. That is 46 plus M, then plus K is 180. The reason, sum of angles on a straight line the reason of our decision is important. Examiners want to see it. So we continue from this line, 46 degree plus M. Our K is 28, so we change it to 28. All is 180 degrees. So we can say M plus 46 plus 28. 46 plus 28 is 74. So we have 74, all is 180 degrees. So at this point, we can now say M is 180 degrees minus 74 degrees. So when we do that subtraction, we are going to have 106 degrees as the value of M. Now we have gotten the value of M to be 106. Now if you look at this shape, that is shape VRSU, it is a cyclic quadrilateral. Therefore, angle M plus angle X is going to be 180 degrees because they are opposite angles of a cyclic quadrilateral. So we approach it from there. M plus X is going to be 180 degrees. Reason for that, opposite angles of a cyclic quadrilateral. So our hem is 106. Then we are looking for x. So we make x the subject. X will be 180 minus 106. So our x, when you do your subtraction, we are going to have 74 degrees. So we have been able to find the value of x. We have used the fact that angle K is the same as angle 28 because they are angles in alternate segments. Then we have also used the fact that the sum of angles on a straight line add up to give 180. In that case, we are able to get M. Then the sum of angle M and angle X will also be 180 because they are opposite angles of a cyclic quadrilateral. It is expected of you as a student, anytime you are answering question, that you back it up with the reason why you are taking such a decision. When I wrote K is 28 degrees, I put the reason there because they are angles in alternate segments. So you can put this down in your notes and take time to study. Another question to illustrate the application of the circle geometry theorem. The particular question on the board, we are required to find the value of x and y. Now, how do we find the value of x and y? We can start by referring to this angle here as angle T. So this is T. So my solution, I can say let that angle QRS be T. Now if you look at the diagram, we have parallel lines, we have QT and RS. Both of them are parallel lines. You can see the symbol. Immediately I discover we have parallel lines, then I'm going to look at the properties of angles formed by parallel lines and transversal. So in that case, if this angle here is x, this one here will also be x. That means angle RSQ is also going to be x. Why is it x? It's because both of them are alternate angles. So I'm going to write it in brackets, alternate angles. Now, this symbol here shows that QR is the same thing as RS. So QR is RS. That shows that I'm dealing with isosceles triangle. So this angle here will also be x. That is, if this is x, this will also be x. That is, the base angles of isosceles triangle are the same. So I can now write RQS. RQS is going to be x. The reason, base angles of isosceles triangle. So with this arrangement, if I look at the diagram again, RQTS is a cyclic quadrilateral. So the opposite angles of a cyclic quadrilateral will add up to give 180. So I can write that T plus 52 degrees is 180 degrees. Reason for that, opposite angles of a cyclic quadrilateral so we can find the value of T from here. T is 180 degrees minus 52 degrees, and T is going to be 128 degrees. Now at this point we have gotten the value of T. Mind you, we are looking for X and Y. Now looking at this triangle here, that is triangle QRS, we can say angle T plus angle X is going to be 180. The reason is that the sum of angles in a triangle is 180. So I'll write the reason. Sum of angles in a triangle. So from here, X plus X is 2X. Then T is 128. All is 180 degrees. So from here, we can say 2X is 180 degrees minus 128. And that implies that 2X is going to be 180 minus 28. 128 is 52 degrees. So at this point, it implies that X is 52 divided by 2. And that implies that X is 26 degrees. That implies we have been able to find the value of X, remaining Y. Looking at the position of Y and X, this is a diameter. PS is a diameter because that line passes through the center O. Since I have a diameter, what should come to my mind is the angle in a semicircle. And we have said that angle in a semicircle is right angle. That implies it is 90 degrees. So angle Y plus X is going to be 90 because the two of them combine to form angle in a semicircle. So in that case, I can now write Y plus X is 90 degrees. The reason for that, angle in a semicircle. Then we are now going to solve Y plus X. X is 26 degrees. Everything is 90 degrees. So that implies that Y is going to be 90 degrees minus 26 degrees. And that implies that Y is going to be 10 minus 6 is 4. Then 8 minus 2 is 6. So we have Y to be 64 degrees. Now in this case, we have been able to answer this question by finding the values of X and Y. Take note of the solution and put the notes in your writing materials. Let's look at question number 3. Question number 3, we are required to find the value of y. This is angle y. It is UXY. That is the angle we are looking for. Now, when you look at the arrangement of this diagram, what you come to mind is the angles in alternate segment. So in this case, this angle here, which is angle XUV, is going to be 50 degrees because angle XUV is the same as angle VXW. They are both angles in alternate segment. So let me write it down. Angle XUV is 50 degrees. Reason: angles in alternate segment. Likewise, if you look at angle UVX, angle UVX, which is this, is also going to be y. It will be equal to angle YXU. So I can also report that as UVX is going to be y. The same reason, angles in alternate segment. So at this point, looking at this triangle UVX, it is an isosceles triangle because this symbol shows that these two lengths are equal. That is, UV is equal to VX. So for an isosceles triangle, the base angles are equal. So if this base angle here is 50, automatically this one here will also be 50, because the base angle of an isosceles triangle are meant to be equal. After doing this, let me write the reason. Angle UXV is 50 degree. The reason: base angles of isosceles triangle. So at this point, we are ready to find the value of y. Looking at the triangle, the sum of the three angles in a triangle will add up to give 180 degrees. So we can say angle 50 plus 50 plus y is going to be 180. So we write that out. Y plus 50 degrees plus 50 degrees is 180 degrees. The reason: sum of angles in a triangle. So 50 plus 50 is going to be 100. So at this point, y is 180 minus 100 degrees, and y is 80 degrees. So we've been able to find the value of y using the circle theorems, which we have learned earlier on. Let's look at question number 4. In question number 4, we are asked to find the value of m. Angle XWZ is given as m, and angle XOZ is also given as 10m. In this question, we are asked to find the value of m. Now, before we start, we can call this angle here angle K. there's a relationship between angle K and angle M. Angle K is going to be 2 times M because angle K is at the center and angle M is at the circumference. And mind you, angle K is subtended at the center by this arc XZ. The same arc XZ subtends angle M on the circumference. So in that case, we can say, let angle XOZ be K. Then K is going to be 2M. The reason for that is that angle at center is twice the one at circumference. So K is 2M. Now, there's a relationship between K and 10M. K plus 10M is going to be 360. That is sum of angles at a point. Our K is 2M, so I'm going to change it to 2M. 2M plus 10M is 360. 2M plus 10M will be 12M, is 360 degrees. Then M is 360 degrees divided by 12. So in that case, M is going to be 30 degrees. So we have been able to find the value of M in this particular question. Looking at this question, you discover that we have angle at the center, and likewise we have another angle at the circumference. Though we can also see that we have a quadrilateral, 1, 2, 3, 4. But we have not been able to use the properties or the theorems concerning cyclic quadrilateral here. So, but what we focus upon is to look at the angle which an arc of a circle subtends at the center and the angle which that same arc subtends at the circumference. The relationship between the two of them is that the one at the center is twice the one at the circumference. Remember, at the beginning of this particular revision series, we talked about 8 theorems that a student is expected to know to answer questions on circle geometry. One of them is that angle in a semicircle is a right angle. Another one is that angle in the same segment are equal. Another one is that the opposite angles of a cyclic quadrilateral are supplementary. We also talked about the exterior angle of a cyclic quadrilateral being equal to the interior opposite angle. Now, all these theorems I've mentioned, they have deductive proof to show that they are actually valid. A student is expected to know them. A student is expected to figure them out in a cyclic geometry problem. Most of the questions you are going to come across is going to be in form of a diagram. So it is expected of you, after knowing the theorem, you should be able to figure out the theorem in the diagram. When you are able to do this with constant practice, then you will be sure of answering questions involving cyclic quadrilateral.
That's the much we can take today on the program. Join us next time for another educating session.